Hello, my name is Lauren Wright.
And I'm Gracie Rocco. Today we will be demonstrating the decomposition of copper-2 carbonate hydroxide hydrate.
A decomposition reaction is defined as a chemical reaction in which a substance breaks apart into simpler components.
The general formula for a decomposition reaction consists of a substance, such as AB, breaking apart into its elements or new compounds, A plus B.
In order to break apart the bonds within the compound, an energy source such as light, electricity, or in our experiment, heat, is used.
Our first step to perform the reaction is to gather our materials. For this experiment, we will need a balance to measure the change in mass, a crucible to hold the copper-2 carbonate hydroxide hydrate, and a Bunsen burner to heat the compound.
To begin, we start by measuring the mass of the crucible by itself, which turns out to be 88 grams. Next, we add 5 grams of copper-2 carbonate hydroxide hydrate and remeasure our mass. This turns out to be 93 grams. We will record both of these masses in our data table.
After that, we set up our Bunsen burner with our crucible over the top. We double-click the crucible to allow the contents to be visible during the heating. We light our Bunsen burner to the lowest setting and wait to see if there is a chemical reaction, which is indicated by a change in color.
As we will see, after about 22 seconds, the compound turns black and releases a mixture of H2O vapor and CO2. Because of this change in color and release of gas, we can conclude that there was a chemical reaction.
After the crucible has cooled, we reweigh the compound to calculate the change in mass. Which turns out to be 91.327 grams. The contents of the crucible now weigh 3.327 grams.
Now we can move on and identify exactly what happened in lab. You can see here we have our balanced chemical equation for the decomposition with 1 molecule of copper-2 carbonate hydroxide hydrate breaking apart into 3 different products, 2 molecules of copper oxide, 1 molecule of carbon dioxide, and 2 water molecules.
The initial compound was in a solid state. However, after the reaction, only the copper oxide was solid and the CO2 and water were in a gaseous state.
According to the law of conservation of mass, we must have the same amount of substance on both sides of the chemical reaction. We can use this law to determine the lost mass from the CO2 and water vapor.
To do this, we need to use molar ratios and masses to convert our initial 5 grams of copper-2 carbonate hydroxide hydrate into grams of CO2 and H2O. Before we start, we can calculate the molar mass of each component of the experiment. Copper-2 carbonate hydroxide hydrate is 221.114 grams per mole. CO2 is 44.009 grams per mole, and H2O is 18.015 grams per mole.
To get grams of copper-2 carbonate hydroxide hydrate to grams of CO2 or water, we first change copper-2 carbonate hydroxide hydrate into moles using our molar mass. Next, we use our chemical equation to relate moles of mass of copper-2 carbonate hydroxide hydrate to moles of CO2 and H2O. We then use each compound's respective molar masses to convert to grams.
We find that the mass of carbon dioxide is 0.995 grams of CO2 and water is 0.815 grams of H2O. If we subtract this from our initial mass of 5 grams of copper-2 carbonate hydroxide hydrate, we get 3.91 grams of CuO. This number is very close to our lab calculated value of 3.327 grams. When we calculate the percent yield, we end up with 104%.